Good morning students, welcome to today's session. I hope every one of you understood what and all we have seen so far in the last classes under quadratic equations. And we have seen so many problems under quadratic equations. The content of that lesson is nothing but how to solve a quadratic equation and how to find out roots of the quadratic equation. Okay, so many different problems we have seen in the last chapter. So today I am going to teach a new lesson to you. So we are going to see chapter number 5, that is arithmetic progression. So what is arithmetic progression? So listen here. So look at the series. So here some of the series are there. Okay. So totally 5 series are given here, right? And out of that, so 5 series are given here, 1, 2, 3, 4, 5 series. So is it possible to say the next number of the series, all the 5 series? So here 1, 2, 3, 4, definitely the next number is nothing but 5. And what about here, the next one? So 100, 70, 40, 10. So here, so definitely actually here 100, and if you subtract 30 from 100 means you get 70. 70 minus 30, 40. 40 minus 30, 10. And 10 minus 30. So 10 minus 30 equal to minus 20. So minus 20 is the next value of the series. And here minus 3, and if you add minus 3 with the plus 1 means we get minus 2. And again plus 1 with the minus 2 means minus 1. And here plus 1 means we get 0. And again if you add plus 1 with this one means we get 1. So 1 is the next number. And similarly here, so 3 plus 0, 3. 3 plus 0, 3. And 3 plus 0, 3. Again 3. And what about here? Minus 1.0 and minus 1.5. That is here we add 0.5 minus 0 point with the number. So minus 1.5. And what about here? So if you add this one means minus 2 and minus 2.5. So the next number is definitely minus 3. That is minus 3.0, etc. So in all the series we can find out the next of the number. Okay. So can we say here, for example, minus 2, comma 4, 10, minus 1. So what about the next number of this series? Is it possible to find out? So definitely not, because the difference between these two numbers is nothing but 6. Okay, if you add 6 with minus 2 means we get 4. And suppose, what about here? 10, okay. And what about here? 4 plus 6, 10. And 10 plus 6, 16 only will come here. But here minus 1 is there. So it is not at all possible to find out the next number of this series. But here out of the 5 series, okay, or all the 5 series are in a certain order. That is, in the first one, we have to add 1 with all the numbers. That is, if you need to find out the particular number means we should add 1 with the previous number. And if you need to this number means we should add minus 30 with the previous number. And here plus 1, here 0, here minus 0.5. Okay, so if you see all the 5 series, the common difference between the two numbers are same. Okay, so here 1 is the common difference, here minus 30 is the common difference, and here plus 1 is the common difference, and here 0 is the common difference, and in the fifth series minus 0.5 is the common difference. So a series is obtained by or with a common difference means the series is said to be in arithmetic progression, that is AP. Okay, so look at the definition. An arithmetic progression. An arithmetic progression is a list of numbers, and in which each term, okay, each term is obtained by how can we obtain? Adding a fixed number to the preceding term. Okay, adding the fixed number to the preceding term, right? So look at the examples here. So here, if you need 4 means how can you obtain 4? Add plus 1 with the 3, so we'll get 4. And similarly, how we obtain 3 here? Add plus 1 with this number, that is 2, will get 3. The similar way, the remaining numbers. Okay, so if we add any one of the number, okay, if we add any one of the number, we'll get the next of the series is nothing but common difference. Okay, So here the fixed number is nothing but a common difference here. So except the first term, right? So for example, another example, suppose 1, 3, 5, what about the next number? 7, next number 9, etc. keep going on. So here, except the first number, remaining numbers everything added by 2 with the previous one, right? So if you need, so how can you get 3 means adding 2 with 1, and how can you got 5 means adding 2 with 3, and how can we got 7 means add 2 with 5. So likewise, this is the fixed number, that is here 2 is the fixed number here. So arithmetic progression is a list of numbers. So arithmetic progression is a list of numbers obtained by adding a fixed number to the preceding one except the first term. The fixed number is called the common difference. Okay, common difference of the AP. So AP is nothing but short form of arithmetic progression. Okay, and that D value, it may be positive or negative or 0. In the previous example, so here minus 30 is the common difference, so negative number, and here plus 1 is the common difference. And what about here? So here 0 is the common difference. So the common difference, it may be positive number, negative number, or 0 also, right? So this is the definition of AP, that is arithmetic progression. So if you want to check whether a given series is an AP or not, it is enough to check the common difference. Okay. So here the chapter contains 2 sections. One is nth term of an AP, and another one sum of first n terms of an AP. Okay, these 2 sections only are available. So under these 2 sections, so many sums, different kind of sums are available. Okay, now we are going to see one by one. So let us see the first section now, that is nth term of an AP. Okay, so the general form of an AP. So how can we write the general form of an AP? Okay, so let us consider the series now. For example, 2, 5, 8, 11, 14, etc. Okay, so here 2 is the first number. Okay, the second number 5 can be obtained by adding 3. Okay, plus 3 with the previous number. So 2 plus 3, 5, and 5 plus 3, 8, and 8 plus 3, 11, 11 plus 3, 14. So next number 14 plus 3, 17, it keep going on. So this series is an AP. So here the common difference is nothing but 3. Okay, so how can we write the general form? So let us take the first number as A. So how can we obtain the second number? By adding the common difference. The common difference denoted by the letter D. Therefore, the second number is nothing but A plus D. And third number, so we can add D with this one. Okay, so A plus D is nothing but A plus 2D. And next fourth number, how can we obtain? So we have to add plus D with the previous one, that is with this one. So A plus 3D and A plus 4D. It's keep going on. Okay, so here first term means A only will come without anything, and second term we have to add the common difference, so A plus D. So second term means A plus D. Okay, A plus D, and third term means A plus 2D, and fourth term means A plus 3D, and fifth term means A plus 5D. Fifth term means, okay, so here second term means here 1D will come, and third term means 2D will come, and fourth term means 3D will come here, and fifth term 4D will come. What about sixth term? So A plus 5D. So how can we write the nth term? So A plus n minus 1 into D. Okay, so this is the nth term of an AP, right? So general form can be denoted by A plus D, A plus 2D, A plus 3D, etc. So this is nothing but the general form of an AP. Okay, so that is the general form of an AP. So next one, nth term. Okay, how we obtain the nth term of an AP means like this only. Okay, so here fifth term means we can write A plus 4D. Okay, so one number we can reduce by the particular term. Sixth term means how can we write A plus 5D, and seventh term means how can we write A plus 6D, and eighth term means A plus 7D. So here 8 means here 7, here 7 means here 6, like that. So how can you write nth term? Okay, so how can you write nth term means A plus n minus 1 into D. So this is the formula for finding the nth term of an AP. Okay, so here you can write A1 or A also, because A is the first term. Always you can denote A as a first term. Okay, and here D is a common difference already given here, and N is that is N minus is the position. Okay, and this is the nth term. Okay, so this is the formula for finding the nth term of an AP, right? So here, or we can write AN equal to A plus N minus 1 into D. So like this also we can write the formula for nth term of an AP. Okay, so we can write either this one or this one. So here where, so A is nothing but first term of the AP and D is nothing but common difference of the AP. Okay, so always the first term denoted by small a and common difference denoted by small d, right? So look at the applications now. Okay, now we are going to use that formulas to solve so many problems here. Okay, so look at the example here. In which of the following situations does the list of numbers involved make an arithmetic progression and why? So here 4 subdivisions are given here. Now we are going to check which situation forming an AP. That's it. Okay, so look at the first one. Look at the first question. We are going to see one by one now. The first question is the taxi fare after each kilometer when the fare is 15 for the first kilometer. Okay, for the first kilometer 15 rupees fare and rupees 8 for each of additional kilometer. Okay, so for the first kilometer 15, what about for second kilometer? So 8 rupees more. Okay, so 15 plus 8, 23. And then what about for third kilometer? So 23 plus 8, 31. Then 39, etc. Keep going on. Okay, so 15 is for the first kilometer and 8 rupees 8 for each of the additional kilometers are given. So we have to add 8 with the previous one. So 15 plus 8, 23, 23 plus 8, 31, 31 plus 8, 39. And what about next one? 39 plus 8, 47, etc. Keep going on. So is it in the AP or not? Yes, it is in AP only. What about the first term of the AP? 15. So first term can be denoted by the letter A. What about the difference of the AP? How can you find the difference? The difference is nothing but formula is there. That is, we have to subtract the first term from the second term. Okay, that is first term, second term, that is 23 minus 15 equal to 8. So 8 is a common difference. Okay, so already I said the formula for that is nth term of an AP, A plus N minus 1 into D, and also what is the formula for D means A2 minus A1. Okay, so A2 means second term. So first term, second term denoted by A1, A2, A3, etc. Okay, so when we compare these two, so A1 is 15, A2 is 23, A3 is 31, A4 is 39, and A5 is 47, etc. Keep going on. Okay, so generally we can denote the APs A1, A2, A3, etc. AN like that. Okay, so now the given situation is an AP. What about the next one? The amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. Okay, so before going to solve this, let us recall the formula again. Okay, so the first term is denoted by A1 or A, and second term A2, third term A3, etc. Nth term denoted by AN. Okay, and also, or how can we define means A plus D, A plus 2D, A plus 3D, etc. Okay, etc. Okay, these are the general form of an AP. And the nth term of AP, how can we find the nth term of an AP means formula is A plus N minus 1 into D. So these are the formulas. Okay, so how can we denote fourth term? That is A4 equal to A plus, instead of N we can substitute 4. So 4 minus 1 into D. So equal to A plus 3D. So fourth term means A plus 3D. And fifth term means A plus 4D. So likewise. So these are the general cases in nth term of an AP. Okay, right. Now before going to solve this problem, you should know these things. Okay, so let's continue the solution. in the next video.